This is Group 5's lab on Poisson Distribution. Bit of an introduction. Data in this report came from the intersection of South Marietta Parkway and Cobb Parkway. The lanes observed for this lab were the westbound through lane and left turn lane on South Marietta Parkway Southeast. And the data was recorded around 3:30 p.m. on a Tuesday. The purpose of this lab is to verify that traffic arrives in a statistically random pattern, as it dictates certain parameters when analyzing a signalized intersection. We are ultimately trying to determine if the vehicle arrives at a signalized intersection follows Poisson distribution, and with that information, conclude whether more investigation needs to take place to determine if the traffic stream is affected by another source. Here's a quick overview of the lanes that we observed. And a quick effort statement. Dahlin contributed by doing the conclusion. Davis had the results. Brad had the objective and introduction. Tori had the discussion. So I'll hand it over to Davis for the results.
Thank you, Brad. While observing this lane group, we collected data for 120-second intervals and counted a total of 275 vehicles arriving to the lane group. In this table, you can see the observed probability for each number of vehicles arriving per interval, as well as the computed Poisson distribution for each interval. For the Poisson calculations, we use an average arrival rate of 0.1375 vehicles per second. So moving on, this is the data summary. So we analyzed this data and we found the observed frequency and the computed frequency of the number of vehicles that arrived for each 20-second interval. And we use these values to test if the Poisson ratio is a good indicator of how vehicles arrive at the intersection. So the null hypothesis for this data, or for analyzing this data, is that the data follows the Poisson distribution. So to test this hypothesis, we compared the chi-squared value of 25.45 to the theoretical chi-squared value of 7.815. Since our computed was greater than our theoretical, we were able to reject the null hypothesis and state that the data does not follow the Poisson distribution. So here are our graphs of the observed frequency versus the computed frequency. And you can see clearly that there's a big difference between the two, especially at the 0 to 2 vehicles arriving. Now I will pass it over to Tori to discuss our findings further.
Thank you, Davis, for the results. From those results, we analyzed that the Poisson equation does not provide a good indication of driver behavior at this intersection, because we found the observed frequencies are a better indicator of the frequency of arrival rate better than Poisson. Secondly, I think this effort is not a practical gauge in traffic engineering because we determined that the intersection was not following the Poisson distribution. However, the statistical functions are potentially useful on a grander scope. More specifically, Poisson distribution cannot be solely used to determine minimum green time alone, as there are contributing factors such as traffic volumes, vehicle arrival patterns, pedestrian crossing times, and safety considerations. As well as according to the Federal Highway Administration, quote, the Poisson method and any other method with the objective of minimizing cycle failures is only appropriate in light traffic conditions where the motorist's expectation is to be served on the next available green. Along with that, we find that the Poisson should be used to find the length of a left turn, as we found from a study on calculating relevant length of a left turn from South Korea. It states, as we all know, Poisson distribution is only suitable for the events that are random and rare. Therefore, using Poisson distribution is not relevant to apply urban intersections, especially commercial areas. Indeed, it is very hard to find a suitable distribution model to fit into real-life situations. Lastly, it is important to note that there may be instances of inaccuracy due to the occasional disruptions in the viewing angle caused by factors such as the presence of semi-trucks and other heavy vehicles in traffic. And I will hand it over to Dallin.
Thank you, Tori. So in conclusion, the data does not follow the Poisson distribution curve. Therefore, the hypothesis is rejected. In this scenario, Poisson statistical analysis does not prove to be useful in traffic analysis. Therefore, further traffic analysis is required to determine maximum arrivals and minimum green time. The observed frequencies are a better indicator of frequency of arrival rate. Further speculation on this intersection suggests that its traffic is potentially impacted from upstream traffic control systems. Thank you very much. These are our references. Everyone have a nice day.